Okay, Assalamualaikum warahmatullahi wabarakatuh and very good afternoon to all of you. So we are still in nodal analysis, okay, method of analysis for the using the nodal method, okay, to solve the circuit theorem. Okay, so I would like to continue some just to refresh back about the nodal analysis. Okay, so I use this circuit as an example. Okay, so we have two current source and three resistors, and the question is find Vx, which is the voltage across 3 ohm. Okay, actually I have already done the solution for you, so let us discuss the solution. Okay, first of all, what we need to do is actually to come out with the circuit diagram where you need to define your node voltage, okay, and also your reference node. So right now, I have two nodes. I define as a V1 and V2 here. And then you need also to define a reference node, which is this point also. So which is, this one is actually a 0 voltage, okay. And then the next step is actually to define the direction of your branch current. Okay, so your branch current need to be consistent. So you shouldn't actually change the direction of the current once you have set the direction of the branch current. Okay, so as you can see, I have set my branch current as shown in this circuit here. Okay, and after you have defined all your current direction, then you can start analyze your node voltage. Okay, we start with V1. So for V1, okay, the KCL at V1 here. So this is the current that you need to know, that this is the current that go into, and then there are two current that go out. Okay, so you need to separate. So as you can see, we have two current go out, V1 over 3, and another one is V1 minus V2 over 4 ohms. And this is equals to 2 amperes, which is your current source, okay? And then after rewrite this equation, so I will obtain the first equation that relate V1 and V2 as follows. Okay? And the same thing happened to V2. Okay? So right now your V2, you have two current going into V2 and one current that going out from V2. So the KCL at node V2 is actually V1 minus V2 over 4 ohms plus 5 amperes, which is the current source, and equals to one current output, which is V2 over 4. And after I rewrite this equation, so finally I obtain my equation at node V2 is equal to V1 minus V2 minus 2V2 is equal to negative 20. Okay, then by using your calculator, you will obtain the V1 and V2. And then from here, we can see that your Vx is actually equals to V1, okay? So because V1, this one is 0 volt, minus 0 is equal to voltage drop across 3 ohms. So V1 is actually your Vx, okay? So that actually we have complete the solution for this circuit, which is very simple and straightforward, okay? Okay, so right now I want to ask you what happened when actually the current source here is replaced with a voltage source. which is 5 volts. Okay, let me clean up this. Okay, so same thing. So you need to define your V1 and also your V2 and the current that. So I set my current direction like this. Okay, and maybe this one also like this. Okay, so KCL at not V1, so it's actually 2 amperes is equals to 2 current go out, V1 over 3 ohms. Okay, or you can say also V1 minus 0 over 3 ohm plus V1 minus V2 over 4. Okay, so after this one, I simplify. So this one will become 24. I think 24. This one is 4V1 plus 3V1 minus 3V2, or this one is actually 7V1 minus 3V2. So this is my first equation that from node V1. Okay, so now V2. Can someone do it for me? The equation for V2. Okay, because the objective of the nodal analysis is to find the unknown node voltage, okay, by using KCL. So right now we have already solved or we have already obtained the equation at node V1. So now we go for node V2. Please be reminded that as you can see from node V2, it is connected with a voltage source. Meaning that you already know your V2. You don't need to to derive the equation of the KCL at node V2. Okay, no need, because as mentioned before, the nodal analysis, the objective is to calculate what is this node voltage, right? For V1, yes, we need to derive the equation. But for V2, if you look carefully at this circuit, this V2 is directly connected with a voltage source. And as you can see also, this 4 ohms is also parallel with voltage source, 5 volts. So meaning that the voltage across 4 ohms is also 5 volts. So meaning that V2 equals or minus 0 is actually equals to voltage across 4 ohm, which is 5 volt. So meaning that your V2 is, you can directly say V2 is 5 volt. Right? So no need to do the KCL because your V2 is already known because V2 is connected directly with the voltage source. So meaning that if you have a circuit that the node is connected directly with the voltage source, so just use that values of the voltage source as your node voltage.
Doctor, and it also should be in ground reference point, right?
Yes, yes, voltage ground here. Thank you very much. So this is 1 is 0. Okay. Okay. So as you can see, we have V2 5 volts. So meaning that from 1, you just substitute the V2 with 5 volts. So 7 V1 minus 3 multiplied with 5. So your V1 should be 24 plus 15. So V1 is this one 39 over 7. Okay, volt. Okay, so that is the point that I want to highlight. Okay. Any anything that not clear before we proceed with the Supernode? When and how to use the Supernode? Which is this one is actually has we actually stop at Supernode. Okay, so so today I want to continue with the Supernode. Okay, so I have already posted the example of nodal analysis. We have 3 examples there. Maybe you can download it first and then open up the nodal one. Okay, nodal one. Okay, so right now I am showing to you. Okay, hold on. Okay, Microsoft Edge. Okay, so I'm showing it to you right now the example of nodal one, which is come from the textbook. Okay, I don't know why. Okay. Okay. So when this supernode is used, so supernode is used when you have a voltage source that is actually non-reference nodes. For example, for this circuit. Okay, so you have what we call, we define this one as your V1, and this is V2, and the node reference is actually this point, 0 voltage. And as you can see, V1 and V2 are not it's actually not a reference nodal. Okay, so meaning that to solve this, you need to use supernode. Okay, why we cannot use, for example, to use current here? Because we know that this is your KCL. So we use the current direction here, and current direction here. So for this direction, yes, you can, for KCL, for example, KCL at node V1. Okay, so I can derive my equation. So this one is positive 14. Okay, so how I get positive 14? This node. If you confuse, please just remind like this. Okay, for example, I also sometimes got confused during my study. Okay, so this one is your Vx, for example. Okay, and this is my node voltage. Okay, so Hussein, can you mute your microphone? Okay, thank you. So from here, I get Vx minus 0 is equal to 14. So that's why my Vx is 14. So meaning that this is actually the value is 14 volt. So 14 minus V1 over 4 ohms, right? And then current input only one, and there are two current that go out from node V1. So we have V1 minus 0 over 3 ohms plus this current. But this current, we cannot calculate because we don't have resistors. Because the current is actually from this KCL, we need have a voltage and also resistor. Okay, but right now this branch current don't have any elements of resistor, so we cannot calculate the value of the current here, the equation. So that is where we need to use Supernode. Okay, so what is Supernode? So we actually represent this V1 and V2 that actually connected with the current voltage source here as a big node. Okay, big supernode, meaning that you have current here 4 ohm, and then you have another one which is 3 ohm here, and then you have another one that 2 ohms. Okay, and then another one is actually go out to 6 ohm, right? So this is the supernode. You regard this point, this V1 and V2 as a supernode, and then you do the KCL at this supernode. Okay, so okay. Okay, so this is not KCL at supernode. Sorry, this is not KCL at node 1. So this is actually KCL at supernode. Okay, so at supernode, so we have one current only that go to the supernode, which is 14 minus V1 over 4 ohms, this branch current. Okay, these branch currents. And we have 3 branch current that go out from the supernode, which is V1 over 3, V2 over 2 ohms, and another one is V2 over 6 ohm, this one. Okay, so this one V2, V2, and then this one is V1, and also this one is V1. So can you see? I hope you understand this one. This is a supernode. Okay. Then I simplify this equation. So finally, I will obtain this one. Very simple equations. Okay. So this is equation from supernode. So right now, I have two variables, V1 and V2. But we only derive one equation only. So we need another equations so that we can do the simultaneous operation. Okay, so the second equation usually comes from the supernode itself. Okay, so the supernode here, the relationship between V2 and V1. So since, as you can see, the polarity of the positive is actually at V2, so I usually write my equation V2 minus V1 is equals to 6 volts. Okay, so this is my second equation that come from inside the supernode. So right now I have V1 and V2 for the first equation, and also
Doctor,
V1 and V2 for the second equation. Okay? Okay, yes. Same.
Doctor, can you repeat
This one,
okay,
the second
no,
equation.
yes, how did we get it?
Okay. Okay. So to obtain the relationship within this supernode is actually not, we are not looking at the direction of the current. We are looking at the polarity of the voltage source. So the polarity of the voltage source is actually positive, actually at V2, meaning that V2 is higher than V1, right? So that's why I write like this. V2 minus V1 is equal to 6 volts. It's same like, for example, I have this This is my V2, and this is my volt, and this is my ground, 0 voltage. So usually I will put V2 minus 0 equal to 10 volt.
Okay, doctor, understood.
Okay. So if this one is V1, so V2 minus V1 equal to 10 volt. So I will always look like that. So we have the first and second, then you can use your calculator, simultaneous equations. So you will obtain your V1 is equal to negative 0.4 volt and V2 is 5.6 volt. Okay. And from the circuit, you see that this voltage is actually V1. So your V is actually V1. So the answer is negative 0.4 or negative 400 millivolts. Okay. And the second question is to find the current. The current is actually this branch current that flow through these 2 ohms. So directly you can obtain your I is actually V2 over resistor. So V2 is actually, I think 5.6, I think, over 2 ohms. So you will obtain 2.8 amperes. Okay. Okay, so I already told you to download the LTSpice, right? So LTSpice, I think is actually good for you to learn something about the software in electrical engineering. For electrical engineering, we have a lot of software actually. Okay, we have LTSpice. So this one is a very lightweight software or apps in desktop to analyze circuits. Okay, but it has some limitations and it only can do basics simulation of basic circuits. Okay, we have another advanced simulation, what we call PSpice. So we can say that PSpice is the big brother of this LTSpice. And then we have also what we call MATLAB Simulink. We have what else? Multisim and so on. Okay, but for your syllabus and for your level, so it's, I think it's enough just to introduce you with the LTSpice. So LTSpice is quite straightforward software, so you don't need to be very advanced to learn these softwares. Okay, so if you have installed, so I think when you open up this LTSpice, so we will receive this what call some abstract drawing here, okay, which is very unusual for the engineering software. Okay, so what you need to do is actually, if you want to create a circuit, so what you need to do, just click here, new schematic, okay, and then it shows some blank space here, but this actually has been already, you can actually put your, you can actually begins your what you call the design of the circuit. So let's try to design the circuit as this one. Okay, so just put, if you want to put resistor, so just put resistor, click this resistor. Okay, and then if you want to rotate, just click Ctrl R, so it will rotate for you, and then just click here, and then if you want another one, okay, rotate, so here, and then if you want to remove the resistor, just right click. Okay, so right click, so it will remove it for you. And if you want to actually zoom in, so you can just scroll the mouse in and out. Okay, so I want to move it at the center. So if you want to move the circuit, so you just click here. Okay, so it will actually remove you need to highlight first, drag, and then you can remove the circuit. Okay, and if you want to go to another function, just just right click. Okay, just right click. Okay, another one. So this one you have resistor, another resistor. Okay, right click, and then voltage source. So right now the voltage source. So as you can see here, there is no menu on voltage source, but you can search the voltage source by clicking the component here, and then just type voltage. So there, highlighted. So just click here. Okay, so this one you have voltage source, and then you have the second voltage source. Just Control R. Okay, the polarity, and then just double right click. Okay, so I need to look at the is it different. So this one is negative. Okay, so just click here, Control R. Okay. Okay, so to draw the wires, just click here, wire. So it can draw it for you. You need to press and then release. Okay, and then release, and then go to next point. So I think this one okay, click release, click release. This one also click release. Okay, okay, I think this one, if you want to delete this, just right click. Oh, sorry, if you want to delete the wire, you just press the keyboard button, delete button. Okay, so it will display the scissor, so you can click the wire to delete. Okay, so and then go back to the wires, so rewire again, press and release, press and release. Okay, press, release, release. Okay, this one press. Okay, so right now we have already complete the circuit drawing. So right now the next step is to put the values. Okay, so 14 and 6 volts. So you just go to the voltage source, and then until you have this, what you call this icon. Okay, this the finger icon. So this one, just right click, so it will go to the menu. So this one is, I think, 14, is it 14 volts? And this one is actually right click, 6 volts, if not mistaken. Okay, so 6 volts. Okay, same thing to the resistor. So this one, right click, so 4 ohms. Okay, so this one 3 to 6. Okay, right click, 3. This one, right click, so this one is 2, and this one right click is 6 ohm. So we have already done the circuit. So next is actually to put the reference node. Okay, so for the circuit analysis, you always need to define your reference. So just click here, ground, and then drag it. Okay, and then I think you need to put some wire here to connect it. There it is. Oh, sorry. Okay, so we have complete the circuit. So right now, if you want, you need to simulate it. Okay, so the simulation, you just click this, what I call the icon running. Okay, the person that is in run mode, so run, but it will actually go to this menu. So we have a lot of analysis actually, transient, we have AC analysis, DC sweep, and so on. So usually for this for your syllabus, we just go to the DC operating point analysis only. Okay, so click here, DC operation, okay. Okay, and it will actually calculate all the node voltage for you. But this one, I think, is not very easy to look at. What we do is actually, you can, very easy is actually, just if you want, for example, to see what is the node voltage at this point. So what you need to do is actually just left click the mouse and drag to the point that you want. Okay, left click, do not release. Okay, go to the cable first and then left click, don't release. Okay, so if you want to see the point, the voltage at this point, just click here. So it will give you the values, negative 400 millivolts. This point also, if you want to see the node voltage, okay, so you go to the cable first and then left click. So it will also give the, when you release, it will give you the values. Okay, so this one is 5.59, so it's equal to around 5.6. Okay, and if you want to see the power dissipation of the element, you can also do that by going to the resistor R2, for example. Okay, R2, and then until the icon of this hand appears. So the value of the power dissipation is actually at this very low part of your taskbar here. Okay, so look at this low part. So if I place my icon here, so it will give you the result that the power dissipation is around 53.33 milliwatts. Okay, and then the current that flows inside the R2 is 133.3 milliamperes. Okay, and same case goes to R4, for example. So R4, the power dissipation is 5.2 something. Okay, so it's very easy for you to double check your calculation. Okay, and this is actually the assignment. Okay, so I will give you several questions. Okay, maybe mix of the exercise from the textbook and also from the previous year final exam. So calculate manually and verify by using these simulation results. Okay, so this one, okay, so this one volt, because it's already, we define 0, right? So you can actually, anything, any node that you want to find, so just click here. So this one is 14. Okay, but the limitation of this the limitation of this software is actually, it can only give you the node voltage only. So for example, to get the voltage drop across R1, so you need to do the basic ohms analysis. Okay, 14 volt minus negative 400 millivolt over 4. Okay, so you can get the current and so on. Okay, so the assignment that I will give you later this week is actually individual assignment. Okay, individual assignment. Okay, so I think that's all for the LTSpice. So it's very easy. So we go back to the discussion on the nodal. So right now I am showing you the second example. Okay, for the deadline, don't worry. So the deadline, maybe I give you around maybe 2 weeks. Okay. Okay, so right now I'm showing the second example. Apply nodal analysis to find I/O and the power dissipated in each resistor. So as you can see here, you have a voltage source that are connected with non-reference node. Okay, so you need to consider this as a supernode. Okay, so as mentioned here in the solution, I have already defined my node V1, V2, and V3 and the direction of the current. Okay, so you can refer to my solution. Okay, so please regard this as a supernode. So you have you have 4 currents go out from the supernode. Okay, so this one is 6S, okay, not 6 ohm, 6S, Siemens, which is 1 over R actually. So that's why this one is actually 6V1. Okay, because this actually 6S is actually 1 over R. Okay, so you have 4 current going out. So as you can see, you have 4 is equal to 0 here because there is no current going in, and so on. And then for V3 also, you need to calculate the KCL at not V2, V3. So you have 2 currents, 2 amperes and also this current. Oh, 3 currents. 2 current that going into, which is 2 amperes and 4 amperes. Oh, 3 current, okay, sorry. 3 current that going into the node. 2 amperes, 4 amperes, and this current. And there is no current that go out. Okay. So finally, I obtain, this is the equation, the first equation from the supernode. Okay, so you have 3 variables, V1, V2, and V3. So meaning that I need to have 3 equations. Okay, the second equations come from the node V3. Okay, and the last equations come from the supernode itself. So the supernode is actually V1 minus V2 is equal to 10. Okay, V1 minus V2 is equal to 10. Then you use your calculator, you will obtain this one. Okay, so your IO, the current here is actually, so since this is actually 1 over R, so just multiply. So SV is equal to 29.4 amperes. Okay, so and then this is the power dissipated. Okay, so this is the nodal example 3, which is come from your text, from your textbook, study cool. So it's very easy and straightforward. Okay, so I hope you can study on this. Okay, and one more thing that I want to highlight, which is not, I forgot to mention. If you have oh, it's okay. No, it's okay, it's okay. I think this one covered. The example, this one covered. So you can look at this example. Okay, you have, for example, you have a current source, and then you have a resistor that is actually connected in parallel with the current source. So is actually this is actually the solution. Okay, which is nothing special. It's just straightforward. Okay, but sometimes because the student quite confused, so we have a resistor here, but the same current that go into the resistor and the same current go into the go out from the resistor. So how to do that? Okay, but it's actually a very simple one. Okay, you can see my solution. Okay, so this is the equation from node V1, and this is the equation from node V2. So you have V1 and V2, 2 equations, then you can solve by using your calculator. Okay, guys, I think that's all for my discussion on example of the nodal analysis. My highlight today is actually to show you the supernode. Okay, that is my highlight for my online class today, the supernode. Okay, so you may watch after this. So I want to change the way of I deliver the teaching materials. So starting from this week, I will pre-recorded my lecture notes, okay, my lecture videos, and then I will you need to watch that before the next class, okay, before the next class. So and then during that class, after that, so if anything that you didn't understand, okay, based on maybe on the examples or maybe from your reading and so on, you can ask me during our during on that class. For example, after this, okay, you need to watch the mesh analysis videos, which is I have already uploaded in my YouTube channel. If you don't have the link, so I will post it again, the playlist, and then you need to scroll down to the latest video, which is the mesh analysis. Okay. Uh, from that, I think I have created two videos for the mesh analysis. The first one is the mesh analysis, and the second one is the what you call the super mesh. Okay. So you watch that videos. Okay. So on our next class, which is tomorrow, okay, tomorrow, so we will only discuss on the examples, or maybe I will get another uh, exercise and then we discuss during the class, okay, and then maybe that discussion will take around 1 hours, okay, and then after that you need to watch the next video, which is I think the Thevenin circuit, I think Thevenin and Norton circuit. Okay. Any thing that you are not understand?
Doctor,
Yes. Okay.
for the question two of the Supernode, I get a different answer.
Supernode. This one. Okay. What is your answer? What is your answer?
I get voltage one is 2.7755.
2.755. V2.
V2 is negative 2.531 and V3 is negative 0.5306.
How you do that? I think maybe you something wrong here, because this one I have already checked with the answer, because every question that is odd numbers, 3.15 odd numbers, the answer is actually at the back of the book. Okay, which is my answer is correct.
Maybe I try.
Yeah, maybe you did something wrong on these equations. I have checked my answer. This one is all correct, except this one. This one is actually, I don't know, but since this is correct and then this is correct, so I think this one should be correct, right? But I don't know.
Yeah, doctor, I found out my mistake already. Sorry.
Okay. Okay. So I hope you understand the way of I'm changing the class teaching delivery. Okay. So after this, so you have another 1 hour plus. So you need to watch the mesh analysis. So we have already complete the nodal analysis. So next, you need to watch after this class. You need to watch the mesh analysis. Okay. And then if you don't have, if you don't understand about mesh analysis, then we will discuss around 1 hour on our next class. Okay. And then
Next
it's
class
okay.
or
Then
next week?
sorry,
This mesh analysis
mesh
for
analysis.
for the next class or next week?
Next class. Next class.
Okay.
This is our first class, right? On Sunday. So our next class is on
Monday
tomorrow.
tomorrow.
Tomorrow. Yeah, tomorrow. Okay, so mesh analysis, I have pre-recorded. pre-recorded. So you just watch it, and then I have already inside that I have already also show you some examples. Okay, but if you don't understand, then we can online during our class online on Monday. Okay, online. So if you have anything that you want to ask, then you can ask me on Monday. And then if you don't have any question, then we will actually I give you some another examples so we can discuss on the solutions. And after that, that one is actually take around 1 hour. Okay, and then after that, we finish the class, and then you need to watch the next video, which is the next topic, which is the Thevenin and Norton analysis. Okay.
I want to ask about the test one. Is
Okay.
it on 24th of November, right?
Yes, 24th of November, 5 p.m.
5
Doctor,
p.m.
what chapter is included?
Okay, chapter that included, there are 2 questions. The first question is on the basic Ohm's law. Okay, basic Ohm's law, which is as what we have did during our class. So calculate the R equivalence, calculate the voltage across this resistor, calculate the power absorbed by the resistor, and so on. Okay. The second question is on the method of analysis. So method of analysis, we have 2, right? We have nodal and mesh. Okay, but for this test, only nodal analysis will be tested. Nodal analysis. Okay.
Doctor, this delta Y.
No, delta Y, there is no question on delta Y transformation.
Thank you, Doctor.
Okay. Good question, actually. So just for your information, delta to Y transformation, you no need to actually memorize the equations. Usually we will give you the equation if there is included inside your questions. But for test 1, there will be no delta to Y or Y to delta transformation.
Doctor, cancel it, please. No need for it.
Sorry?
Nothing.
Okay, so actually the circuit we have discussed the questions. Okay, the circuit is actually not very difficult, but the way of the circuit is connected, it may give you some what you call confusion. Okay, for example, like this circuit, I think this one, if some of you may have do the exercise because they submit to me and then ask my opinion about how they do it, how they did it. Okay, for example, this circuit. So you need to calculate what is the R equivalent. Okay, from this point to this point. So 5, 20, maybe this one 10. So if some of you might confuse, what is this? So is it parallel or series and so on? Okay. So actually you can simplify the circuit like this one. So you can ignore this one. This one is actually a short circuit. So it's actually just a node. Okay, it's just a node. And then we need that 10 and 5 is parallel, and also 20 and 10 is actually parallel. Just like that. So this is your R equivalent. Okay. Because some of you may think that this is Y to delta, you need to Y to delta transformation. But since this has no element here, so it's actually a node. Okay, just a node. So meaning that 10 and 5 is actually parallel, and so on. Okay. Actually, another example is actually the way of the circuit is drawn. Okay. So it might confuse you. For example, like this, you have I don't remember. Might like this. Okay. So actually, the way of the circuit is drawn may confuse you, but as you can see, this, for example, this one is 10 and this one is 5. It's actually parallel. 10 and 5 is actually parallel. Okay. And then maybe you have some like this. Okay, you have a 10 resistor parallel with a short circuit. So definitely, this one, if you parallel up with this anything short circuit, so your R is actually 0 here. Okay, because the current will flow through the short circuit. It will pass the 10 resistor. So that's why the equivalent resistor that C for this point is actually 0. Because the current will go pass through the short circuit. It will not go to 10 ohms because the current will always flow through the branch that actually has lowest resistance. Okay. So usually students will get confused when we have some short circuit. Okay, some point we have a circuit that is actually short. So what is the equivalent resistor from there? Okay, I think that's all from me. Any questions? So your test will be online, okay? No face-to-face, will be online. And usually I will give you the submission of the test will be using Google Form, okay? Even though some of the subject or courses use e-learning, but I think for me, I prefer to use Google Form because usually e-learning is not stable sometimes when there are a lot of traffics, okay? Internet traffics. So its learning will be very, very delayed. And it's also for some students, the computer e-learning is actually very, very heavy. Okay. So for the submission. So, okay, for the submission, I will give you the SOP since you are the first year students. Okay. So I will give you the SOP. Usually I will give you the question with a password. Okay, so you cannot open the question. Usually half an hour before the test, I will post inside the WhatsApp group. Okay, and then maybe 15 minutes before the test, so you can enter the room, so the invigilation room using Webex. So you need to turn on the camera so that I can see you. Okay, and then 5 minutes before the test, I will give you the password and so on. And then for the submission, plus minus around 15 minutes, okay, to scan using your handphone scanner, PDF, scan to PDF version, and then upload through the Google Form. That is actually the way we did for the previous semesters. Okay. Okay, so if there is no question, so after this, you just go watch the YouTube. I will give you the link, my playlist link. So, and then you need to scroll down the latest videos, okay? Okay, thank you very much. Assalamualaikum and have a very good day.
Waalaikumsalam. Thank you, Doctor.
Okay.
Thank you, Doctor.